is it we're going to do in this one?
Alright, so we're going to complete the table.
Yeah.
That is, you see here, so the preparation of sample dilutions.
Okay.
So the first thing we're going to do, if we have a look, the table is divided into two. And you guys will have a picture of that table on there. And you can see that rows A, B and C contain BSA standards.
Okay.
So that means that we have the BSA, we know it's 2 mg per mil.
Okay, and that's there.
Yeah, which is here. So we know it's 2 mg per mil, and we use this to create a standard curve.
Beautiful.
So here is our 96 well plate. Let's open this up.
Okay, and it has 96 wells? Obviously.
Correct, it has 96 wells, and you can also see that it's labelled A to H, and there's 12 layers, 12 wells
How
that go across the
convenient,
side.
just like the table in our book.
Exactly, looks exactly like that one. Okay, so let's get rid of this lid. What I'm going to do is take this marker so that I can find it easy so I can see what these look like.
Beautiful.
Okay, so first of all it tells me that I need to put 100 microlitres of PBS into each of those wells A, B and C up until row 9. Okay, so I'm going to take my pipette, check that it's got 100 microlitres. I know that my pipette says 10 microlitres to 100 microlitres. Okay, so pipette tips.
Beautiful.
Oh, it's on nice and tight. Here I've got my PBS. So I'm going to start by placing 100 microlitres of PBS into each of these wells. Bloopers 101. Always make sure your pipette tip is on.
Probably. Okay, there you go.
So let's continue where we're up to. Okay. Okay, get rid of my tip.
Beautiful.
So that's my 100 microlitres PBS that I have going into each of those wells. So what I want to do now is create this standard curve. So I'm going to keep A1, B1 and C1 as just 100 microlitres PBS. So the concentration of BSA mg per mil, if I have just PBS, Jen, is what?
It's 0.
Correct, that's 0 mg per mil. So on the top of that column, while you're watching this, I want you to write 0 mg per mil for the BSA, okay? Yeah. Now we're going to start, we're going to take 2 mg per mil BSA, and I'm going to put 100 microlitres into wells A2, B2 and C2. So I already have 100 microlitres of PBS in there, and I'm going to add 100 microlitres of 2 mg per mil BSA.
So it's going to be 1 mg per mil.
Correct, that's right. So so the concentration of BSA in mg per mil for A2, B2 and C2 will be 1 mg per mil. So as I'm doing this, I want you to write 1 mg per mil on top of that column of your table. So again, I will take my 100 microlitre pipette. Okay, and I'm going to put that into 2. And I don't have one.
And you're going to do serial dilutions.
And I'm going to do serial dilutions.
So how much are you going to take from each of them?
What I will do to make this a little bit quicker, I'm only going to do row A, okay? So we're supposed to do A, B and C, but you guys are going to be here forever.
Yeah.
Alright, so now we have A2, B2 and C2. We have 100 microlitres of PBS and 100 microlitres of 2 mg per mil BSA. Now I'm going to do a serial dilution. So what does that mean? It means that I'm going to make sure that this is mixed for starters. So I've got a fresh tip. So I'm just going to pipette up and down it to make sure that this is mixed. And the same with this one. And again the same with this one. Okay, so now I'm going to take 100 microlitres of this and I'm going to transfer it into A3, okay? So if I take 100 microlitre of this and I place it into 100 microlitres of PBS, what's my concentration now, Jen?
It's going to be half a mg per mil.
Beautiful, 0.5 mg per mil. So I want you guys to write on the top of column 3, I want you to write 0.5 mg per mil. So now I'll go ahead and I'll do, because we're doing this in triplicate, I'll go ahead and transfer it across to this.
And then you keep on taking 100 microliters and transferring it to the next one.
Correct.
So we're halving the concentration in each one.
We are. And I'm going to change my pipette tip as I go, so I don't carry that across, okay? So now I'm going to go A3 to A4, B3
so that's
to
going to be the
B4.
0.25 milligrams.
Correct. All right. Make sure it's mixed.
Okay, and then that's the next one. Change the tip and we do the 0.125.
Correct.
Okay. Then
5 to 6.
0.0625. Yes.
Okay. 6 to 7. So now, Jen, we're going to take our samples that we've isolated previously. So previously we isolated BSA, myoglobin, cytochrome C, and we had an unknown.
Okay.
So now we're checking for the protein concentration. And so that's what we're going to calculate. That's what this whole lab is about, this calculation of these proteins. So I'm going to take my BSA sample and I'm going to place 20 microliters into D, E and F1, and then I'm going to put 10 microliters of BSA into D2, E2 and F2. So again, we're doing it in triplicate. So we're doing it in triplicate so that if my pipetting is not quite correct, then when we add them up together and then divide by 3...
No big deal.
That's right, no big deal. Beautiful. So when we calculate this as well, we're going to do dilution factors of 5 and dilution factor of 10. So we've already calculated that for you when we've put it together in your table. So you'll see we have 20 microliters of BSA and 80 microliters of PBS in DE and F, and then in, 1, and then in DE and F2, we're going to have 10 microliters of BSA with 90 microliters of PBS. So that takes into account our dilution factor. Does that make sense?
Mm-hmm.
Beautiful. All right. So I'll go ahead and I'll pipette those into it.
Okay.
Okay, so now we're back and I've completed that. I've put 20 microliters and 10 microliters of each of those samples, BSA, myoglobin, cytochrome C and the unknown into those. And so now I've finished that, I'm going to add my BCA reagent.
So we can see it.
Yes, beautiful, so we can see it. So what I do is I have BCA reagent A and I have BCA reagent B, okay, and it's already measured out for us, so all I have to do is just take the lid off this, open the lid off this, tip it in, and there's that beautiful colour. Look at that, isn't that gorgeous?
Oh, I like that colour. That's beautiful.
So let's shake it up.
Gorgeous.
Turns beautiful. It reminds me of cordial.
It reminds me of Kermit.
All right, so now in order to have this work, we have to add our Bradford to each of these wells. So if we go back to the instructions, it tells us that we need to add 100 microliters of the BCA working reagent to each well that we have something in. Okay, so again, 100 microliters. 100 microliters.
Beautiful.
And I'm going to add that to every single one of these wells.
That's the PBS one.
You can see, yeah, beautiful. So the PBS doesn't show us any colour. And then sometimes this takes a little bit of time for it to react. Okay. So I'm going to go ahead and add this to all of these wells, and we'll come back in a moment with one that's complete. When I finish this, we're going to put it in the incubator for half an hour so we can watch the colour develop. And I won't bore you with that. I will just come back in a minute and I will show you what it looks like once it's complete. Okay, hi again guys. I've just finished. I've just taken my plate out of that
Oh, it's
incubator.
very pretty.
Look at that. Isn't that nice?
Oh, nice purple.
So you can see here, this is our control, this is our 0 mg per mil.
Oh, that's just the PBS, isn't
yeah,
it?
just the PBS.
No protein.
Yes. And so here you can see that protein has reacted with that BCA reagent and it's turned
purple.
Beautiful, dark purple. You can see this beautiful curve that goes down like this. So you can see this darkest amount. So this is our 1 mg per mil.
Most protein, yeah.
Yes, and then you can see this. If you were looking at a colour chart, this is actually half the colour of this.
Oh, because we did a serial
Yes,
dilution.
yeah, so this is half, this is half, this is half, this is half, this is half. And we're down to, this is a very pale purple. And here you can see it's almost back at this. This is down to our smallest concentration. Yes. Now here we can see, this is where I put in our 20 microlitres of BSA, and then I put 10 microlitres of BSA. So again, you can see that colour change.
Yep.
And again, 20 microlitres 10, 20 microlitres 10. And here you can see 20 microlitres and 10. This was our unknown, and it looks like we had a lot of protein.
That's bucket loads of protein, isn't it? It's really dark.
It is.
You'd have estimated that it's more than 1 milligram per mil.
Yeah, definitely. Jenny's right. So you can actually have a look at these as compared to this colour, and you can almost guess around about what the concentration is going to be. So you can see that this is well above that 1 mg per mil range that we have there. And then you can have a look. So this is a little bit lighter. You can see it's probably between here and here. So if you were to estimate it, you could say this is our 1, our 0.5, 0.25, 0.125. It's probably a little bit in between. So maybe
0.1.
0.125, maybe yeah, I don't know. I'd be guessing. We can have a look though. We're going to. So I've put this inside the incubator. It's come out. I'm now going to put that into the plate reader, and I'm going to get it to tell me what these absorbance values are. Now we know this is a colorimetric assay. So what it does is it measures the colour, and it's going to tell me pretty much the concentration, and you guys will have a look and it'll tell you all about using that bicinchoninic acid and how that collates in and how we get these different colours, and it'll tell me pretty much how dark this colour is, and that's going to tell me the absorbance, and it's going to tell me the concentration of my protein. Alright, I'll be back in a minute. Alright, so here we are back again. This is my, and I'll put this up for you, so don't worry about trying to pause this screen. I'll put this up so that you can see it. Here you can see A, B and C, and it relates exactly to this plate. Okay, let me turn it around your direction. So, fold that down. Oh, thank you. So here you can see this relates exactly to the plate. So A1 is A1. B1, B1. And then when we come up here, so this is 9 A, B and C, 9 A, B and C, okay? So you guys just need to copy these figures into your tables. So from here you can see that this is nearly 0. It says 0.088, but that's because we already, PBS carries a little bit of colour, so therefore it's going to give us a little bit of an absorbance reading. But if we add these together, we're going to add these three and then divide by 3, and that's going to be our 0, okay? But I'll take you through those calculations. So here you can see our 1 mg per mil, and you can see that the absorbance is up at, this shows how good your pipetting is, really.
Yeah.
So this is our 1 mg per mil, this is our 0.5 mg per mil, and again you can see they're all in the range of each other. So I will give you a copy of these numbers and then we'll go through and we will do the calculations.